JUICE is having problems extending its radar antenna. Astronomers watch a star eat its planet. And a design for a space station with artificial gravity. All this and more in this week's Space Bites. We've covered the launch of the European Space Agency's JUICE mission for the last couple of weeks, and the launch went great, perfectly. We got a really cool selfie of the Earth in the background as JUICE was examining its various parts. But there's a problem, and that is that the spacecraft is having trouble deploying its radar antenna. This is the radar that it's going to be using to scan under the ice when it reaches the Jovian moons, Europa, Callisto, and Ganymede. It's supposed to be 16 meters long, but it's stuck. Now, controllers at the European Space Agency think that this has something to do with a pin that is holding the antenna collapsed down. And as they started the extension, the pin didn't fully unlock, and so it's sort of halfway unfolded. Their plan is that they're going to try accelerating the spacecraft, and that should sort of shake the radar antenna enough that it will sort of cause this pin to finally come loose, and it'll allow the antenna to reach out to its full length. If it can't get this antenna deployed, it's a big problem. Like, it needs the full antenna to properly do all of the science it's going to be doing once it reaches Jupiter's moons. But they've got until 2031 before the spacecraft finally arrives at Jupiter. So plenty of time to keep trying to troubleshoot the problem before then. Astronomers watch a star eat its planet. Now, we know that stars eat planets. We've seen evidence of the debris from consumed planets in the atmospheres of stars. We see stars on orbits that clearly indicate that in just a few million years, they're going to spiral in and be consumed by the star. But finally, astronomers have actually watched this process happen. The star is located about 12,000 light years away, and astronomers watched it brighten by a factor of about 100 over the course of 10 days. And then it slowly started to dim again. And once it had dimmed enough, they were able to detect a change in the chemistry in the outer layers of the star. From this, they were able to calculate that it was probably a hot Jupiter planet, like some of the first planets ever seen, that was orbiting too close to its star. It entered the atmosphere of the star and was destroyed. This is kind of like what's going to happen to the inner planets of the solar system, and maybe even Earth, when the sun reaches its red giant phase in about 5 billion years from now. But it's different because the Earth isn't a hot Jupiter, and the sun isn't dying yet. A space station with artificial gravity. We've talked so many times on every part of this channel about how weightlessness in space is a big problem for astronauts. Without the force of gravity acting constantly on the human body, your muscles weaken, your bones soften, there's various fluid redistribution problems inside your body, problems with your vision, and even if you exercise for hours every day, some of those problems just can't be fixed without being in gravity. So Airbus released the design of a space station this week that they're calling Loop. It looks like a fairly standard space station, like a can containing astronauts and various equipment and instruments. It would probably contain about 100 cubic meters. And so like when you compare, the International Space Station is about 950 cubic meters. So it's a fraction of the internal volume of the International Space Station. It's got 3 levels, including a hardened level where astronauts could go and hide out during a solar storm to minimize the amount of radiation on their body. But what's really novel about this space station design is that it contains a centrifuge. This centrifuge section would spin and allow the astronauts to go and sit inside and experience some fraction of Earth gravity for some amount every day. Although we didn't get this in their press release, we were able to calculate that if it spins about 9 times a minute, you get the equivalent of Mars gravity. And if it spins less than that, maybe you get the equivalent of the moon gravity, and it would have to spin a lot faster to give you the equivalent of Earth gravity. And so what might happen is astronauts will be floating around inside the space station, and then they go into the centrifuge and spend some amount of time in there getting some amount of gravity, And these are all big questions. Like, we don't know. Like, what is the amount of artificial gravity that astronauts would need to be able to prevent some of these long-term problems with being in space? Is there a sweet spot? What is the smallest possible centrifuge that would do the trick? These are all unknowns. And up until this point, nobody has a serious design for how you would incorporate some kind of artificial gravity centrifuge into a space station. So it's great that Airbus has provided this with their loop concept. That said, this is just a concept. There are no plans to build this thing, no plans to launch this thing. So right now it's just an idea for what an artificial gravity station might look like. Sure, why don't they just launch a Starship, maybe launch 2 Starships and tie them together and have them spin around, or maybe like nail 15 Starships together and put them in a big loop that's spinning and you just exist inside. Like, we got to get somewhere from here. Speaking of Starships, Musk gave us some updates on Starship. So this week, Elon Musk went on to Twitter Spaces and spent about an hour explaining what happened with the initial Starship launch. So we got some more details from Musk himself. A few things that we learned. We noticed that 3 of the engines weren't operating off the pad, and people were wondering whether or not that they had kept those engines off intentionally to see if it could handle launching with less engines. Nope, turns out those engines just weren't operating, and so they kept them off from the launch. Musk said that the damage to the infrastructure at the Boca Chica pad was fairly minimal. Now, obviously, like, we see that gigantic crater underneath where the launch pad, that doesn't look minimal to me, but we see pieces of rock hit the launch tower. We saw that some of the tanks around the pad were hit as well. Musk said it wasn't a big deal. Musk said there was no evidence that a swirling tornado of concrete took out the engines while they were still on the ground. Okay. I mean, I guess there's no evidence of that. We see chunks of concrete fly all the way out hundreds of meters away and hit the ocean. But if they didn't hit the rocket engines that were right there, that's good. He said that they lost communication with several of the engines about 30 seconds into flight, and we did see a bunch of the other engines go offline, but didn't say like what took them out. They lost thrust vector control for the rocket at about the 85-second mark. He also said that there was a pretty big delay from when they initiated the flight termination to when the rocket actually was destroyed. It took about 40 seconds from when they told it to blow itself up to when it actually blew itself up. So what comes next? Well, the next plan is to install a gigantic steel plate underneath where the rocket is going to launch from, cool it down, and hopefully that will mitigate the damage to the launch pad. We'll see. They think it's going to work. Good luck. Says that they should be ready to go and launch again within 6 to 8 weeks, but the big delay is probably going to come from the FAA with all of the additional regulations that they're going to be putting on top of them. They've said this before, and often blaming the FAA is a way to explain the longer flight times. We saw this last year when the FAA gave them a delay. Everyone said it was going to be a problem, and then when that flight delay was resolved, it still took about a year for Starship to be able to launch. So again, Musk says 6 to 8 weeks. I will follow my Musk estimation time rule, double and add 10. Feel free to flame me in the comments. If you missed it, I had a great conversation with Marcus House and Scott Manley about the launch, and we were trying to figure out what was going on. It'd be interesting to sort of go back and look at the questions that we had, the speculation that we made compared to the stuff that Elon Musk has confirmed. So to everyone at SpaceX, I look forward to the next successful test of Starship, an exoplanet that breaks all the rules. Astronomers know of over 5,000 exoplanets at this point, with many more candidates as well. And the vast majority of these are very similar to the solar system, where you've got the star at the middle, and then you've got the plane of the ecliptic around it, and all of the planets are orbiting around this orbital plane. And that's because, like, the whole system formed from one blob of gas and dust, and as it spun faster and faster, it flattened out into this disk. But every now and then, astronomers have found planets that are not lined up with the plane of the ecliptic around the star. And in this case, they found one that is completely outside the bounds. The planet is called WASP 131b, and astronomers have known about it since about 2018. And when they first discovered it, they were able to measure the size, the mass of the planet, what its orbital period was. But more recently, they've been able to figure out the rotation and orientation of the star itself. And so even though the planet is passing directly in front of the star from our perspective, they realize that the star is not seen edge on. In fact, we're seeing it at a really strange angle. And so when you do all the math, the planet is orbiting at 160 degrees away from the orbit of the star. In other words, if it was orbiting on a polar axis, that would be 90 degrees. If it was orbiting completely backwards, that would be 180 degrees. So it is orbiting essentially backwards, but at an extreme eccentric angle of about 20 degrees. So imagine Pluto's orbit, but backwards. And what does it take to make a planet orbit its star backwards from the rotation of the star and presumably the rest of the planets in the system? We don't know. Some close encounter with another star, some extreme planetary collision early on in the star system's history. But astronomers have found that about a quarter of the hot Jupiters that have been seen have these really extreme orbital periods. And so it might be that whatever is causing these hot Jupiter planets to get close into the star also has something to do with them being kicked off of their standard orbits into these really highly extreme orbits. Black hole destroys a star. Astronomers know that there is probably a supermassive black hole at the heart of every galaxy in the universe. Mostly. There's a few that don't have them, but mostly. And we know that every now and then a star gets too close to this black hole, it gets torn up and consumed by the black hole. It's believed that this happens about once every 10,000 years or so on average per black hole. Astronomers have seen this event happen several times across the universe, but because it happens so rarely and because the universe is so big, they're very far away. But astronomers found one that happened relatively close to us. It happened just in our universal backyard, merely 137 million light years away. Of course, 137 billion light years away, that's really far away, but still, that's the closest that astronomers have ever seen it. And so they were able to study this event with unprecedented detail. They found this event by looking through the archives of NASA's NEOWISE mission. They noticed this spot in the sky that blazed in infrared light for a short period of time and then faded away again. What they think happened is that they're seeing the core of the galaxy shrouded by a thick amount of gas and dust. And so then the star got too close to the black hole, was torn apart. Although the X-rays and the ultraviolet radiation was blocked by this cloud of gas and dust, the infrared heated it up, and that was able to be emitted and detected by NEOWISE. And so you can imagine at some point over the last 10,000 years or the next 10,000 years, astronomers will watch a similar event happen with the supermassive black hole at the heart of the Milky Way. Hopefully we'll be around to watch it. I hope you've noticed we've been doing a lot of really great interviews here on the channel. Like this week, we published an amazing interview with Slava Turyshev. He, of course, is behind the idea of the solar gravitational lens. Talked to researchers about manufacturing drugs on demand at the International Space Station. Talked about ways that we could mitigate dust on the moon and Mars, and we've got many more interviews coming. In fact, you can access all of these interviews in one single playlist. And I don't know, do you tend to skip the interviews when you see them in the channel? I promise you, they're interesting. You're going to learn a lot of really new information, and in many cases, you'll be quite excited about what's happening in the near future of space and astronomy, because these are the people that are doing the work. And so you can listen in on the discoveries they've made, their hopes for the future, and get a much better sense of what's happening in the field of space and astronomy and space exploration. Of course, our patrons get advance access to these interviews. So if you want to find out about this research, in some cases days, in some cases weeks before anyone else, go to patreon.com/universetoday. China finally tells us what's going on with Zhurong. The The Chinese Space Agency have been operating the Zhurong Mars rover on the surface of the planet for several years now. It landed at around the same time as NASA's Perseverance rover. But unlike Perseverance, Zhurong is equipped with solar panels. And the story we've heard many times before is that Mars dust kills solar-powered rovers. And it looks like this is what happened to the Mars rover. It went offline back in May 2022, and we just got nothing but silence from the Chinese Space Agency. There was like a lack of news and information, and people assumed, okay, it has succumbed to the Mars dust like so many other spacecraft have. We even got some photos from space showing that the rover hasn't moved in months and months. And this week we got news from the Chinese Space Agency that the rover is offline. It's probably dead, although they're hoping that it will recover when Mars spring warms up. It's able to supply power to its solar panels. But the problem is that if the temperatures get too low, then the battery actually dies. And so even when more power returns, even when the temperatures raise up, the battery is dead, and so it just can't continue operating anymore. We got this as part of an announcement from the Chinese Space Agency that they've discovered what could be one of the most exciting things on the surface of Mars. They appear to have found evidence of a dried up pool of water that was sort of in a depression between sand dunes on Mars. It looks like there's like mineralization in the regolith in this spot, which is exactly what you would see if there was once like a briny pool of water and then the water evaporated away. And this is important because it's much closer to the equator on Mars than almost any other place where evidence of water has been seen before. And we know this is fairly recent because the sand dunes don't last very long on Mars. And so at most, this water would have been there within the last couple of million years. And so if it was there that recent, then it might be happening all the time. And so it's kind of ironic that the spacecraft found evidence that there's recent water on the surface of Mars, but it can't go back and check because it's dead. So hopefully another mission will go to the same region and try to gather more information. You can imagine other spacecraft actually digging through this material, examining this mineralization and finding out if, yes, indeed, it is the remnant from some salty, briny pool of water sitting on the surface of Mars. Look into the permanently shadowed craters on the moon. A lot of our attention on the moon is at the permanently shadowed craters at the southern pole. That's because this is the place where it appears there is large amounts of water ice that is locked away into the regolith, and because it's in shadow all the time, the sun hasn't been able to sublimate this water away. But because these craters are in eternal shadow, they're really hard to analyze, especially with the existing fleet of spacecraft that are at the moon right now. Like, they're designed to image in all lighting conditions. But NASA has an instrument called ShadowCam, which is on board the Korean Danuri spacecraft. And ShadowCam is designed to only look in places that are in permanent shadow. It's a very low light camera, and so it has 200 times more sensitivity looking into these permanently shadowed craters than other spacecraft that are at Mars. It uses Earthshine, which is the reflected light coming off the Earth, as an illumination source, as well as nearby mountains and craters and things like that that can add a little bit more light into this area. If you looked at it with your own eyes, it would look completely dark, but because this camera is so sensitive, it can see into these craters with just these very low illumination sources. And from this, scientists were able to detect lots of minerals and other chemicals on the surface of the area, as well as evidence that there's water ice there. So hopefully in the next couple of years, we will see astronauts return to the moon focused on this area around the South Pole. Who knows? Like, we could see a research station in the future that's set up on the rim of one of these craters with astronauts going down in to study the ice, harvesting it for propellant for future missions into the solar system. Like, this part of the moon is the doorway to the rest of the solar system. All right, those are all the news stories that we had today. Now, if you want, you can do a deep dive into any one of these subjects in the show notes down below. You can get even more space news in my weekly email newsletter. I send it out every Friday to more than 60,000 people. I write every word. There are no ads, and it's absolutely free. Subscribe at university.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at universetoday.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent and keeps ads at a bare minimum. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to Paul Davis, Vlad Shipolin, Jay Dennis, David Giltonen, Modso, George, Jeremy Mattern, Jordan Young, Tim Whalen, Dave Verabioff, Andrew M. Gross, and Josh Schultz, who support us at the Master of the Universe level. All your support means the universe to us. All right, that was all the news that we had today. We'll see you next week.